Find the total area of the region between the curve and the x-axis, but we're looking for area, which will have to be positive. So we have to watch out about that. So here's our function, y equals negative x squared plus 9, and the region is on 0 to 5. So we have to see if the function is negative anywhere on that interval, because when we're looking for area, we have to account for that, because area must be positive. So we set the function equal to 0. The solutions are plus or minus 3, but on 0 to 5, we're just talking about x equals 3. So the total area, if you look over here on the picture, we're talking about this area here. The area between the curve and the x-axis, all in here. And also this area in here. Well, when you integrate, this will be positive contributions from the rectangles. Here, the f of x values are negative, so you're going to get negative contributions. So this part will come out negative. So we have to do something about that to make sure this comes out area instead of just a negative contribution. So here's what we're going to do. We're going to break up and integrate it from just 0 to 3 right here. And that's this integral, 0 to 3 of the function. That'll give us a positive contributions. Then from 3 to 5, we'll take the absolute value, these absolute value bars, of the integral of the function, because that way, when this integral, which is 3 to 5 of negative x squared plus 9 dx, that's going to come out negative. But it'll be the area if we take the absolute values. And so that's what we're going to do. So the absolute value will come out positive. So that's what we do. So we just go ahead and get our antiderivative right here. Evaluate from 0 to 3. We do the same thing over here. Evaluate from 3 to 5. But we have the absolute values here. We have these absolute values. Then we work out all the algebra. Work out all the algebra, as you can see. And it comes out to be 98/3. And you really have to be careful that you're remembering to do the evaluations correctly to get all the way down here to 98/3, which is approximately 32.66667. Checking it with the trapezoid method of Riemann sum for n equals 100 subintervals, we'll use the absolute value. So it's as if we went like this. The integral from 0 to 5 all the way of the absolute value of the function dx. That's what we're doing here when you're doing in the Riemann, because the Riemann, we don't care what kind of function we put in there. Absolute value, and of course you deal with the ABS, abs, out of the math menu, and you run the program all the way from 0 to 5. You don't have to break it up, and you will get the approximate answer, and that matches up pretty well to our exact answer. So it verifies out.